We have solved systems of equations by graphing and substitution. Both of these work really nicely when one or both of the equations is already in slope-intercept form and is either easy to graph, or if they're both in slope-intercept form and we can set them equal to one another, we can use substitution. Sometimes, though, we are given equations in standard form and they would either not turn to slope-intercept form very nicely, or they would still be a pain to graph even if they were in slope-intercept form. So these are going to be some more algebraic methods, sort of like substitution, but done with standard form instead of slope-intercept form. Okay, and we're calling this elimination. We are trying to get rid of one of the variables so that we can solve for the other one and then go back and solve for the one we eliminated. There are two situations that happen. You're going to be given two equations, and you're going to look for, first of all, the variable that has the same coefficient, and I mean the same number, but different signs. So I here have 6x minus y equals 5 and 3x plus y equals 4. Well, 6 and 3 are not the same number, right? But I have a minus 1 and a plus 1. So I have a 1 in front of both of the y's. So that's the same number, but they have different signs. I have a minus 1 in front of the first y and a plus 1 in front of the second y. When they have the same number but different signs, you are going to add the equations. Okay, you're going to add the equations. So this is going to be a little different. Remember, these two equations, we're looking for where they intersect. So we're looking for the point that's on both lines. So we're looking for where the x and y sort of work together. So that's why we can look at this and put them together, sort of combine them to help us out. So since these have the same coefficient, different signs, I'm going to add the equations. And I'm going to put a circle around that. That's just something I do so that I know that this goes with everything. So I do a lot of pointing when I do this so I don't lose stuff. So I'm doing 6x plus 3x. So 6x plus 3x is 9x. Then I have negative y plus positive y. So this is a negative y, negative 1y plus a positive 1y. That becomes 0, right? Those become a 0 pair. They go away. Don't lose your equal sign. And then I do 5 plus 4, and I get 9. So notice the y's went away. Now I can solve for x. I only have one variable to worry about, so I'm going to divide both sides by 9, and I get x is 1. But remember, we are solving a system, and a system has a point of intersection. I know my x coordinate is 1. Now I have to find my y coordinate. Well, you look up here and you pick the one you like best, okay? So it will work with either one. I'm going to choose this one because it's got all positive numbers here. And I'm going to take that 3x plus y equals 4. And I'm going to take this one and I'm going to substitute it in for x. So we still have to do some substitution just like we did before. So this is 3 times 1 plus y is 4, and now I'm just going to solve for y. 3 times 1 is 3. I'm going to subtract 3 from both sides, and y is 1. So when x was 1, y was 1. If I were to graph these two lines, that's the solution. That's the point of intersection. All right, let's look at another one. Next one I have 2x plus 4y equals 22 and negative 2x plus 2y equals 8. So I look for the same number but different signs. So see my 2 here in front of the x, I have a positive 2 and a negative 2. When I have the same number but different signs, I'm going to add the two equations. So 2x plus a negative 2x is 0. Those are going to cancel. They're going to become 0. They're going to go away. Then I do 4y plus 2y. That's 6y. And 22 plus 8 is 30. So I eliminated my x's. That's why it's called the elimination method. That's a 30. And now I'm going to solve for y. So I'm going to divide both sides by 6. And y is 5. Okay, so y is 5. I still need x. So you look up here, you get to pick the equation that you like. One of them has bigger numbers, but the other one has a negative. It does not matter. You will get the same answer regardless of the one you choose. So I'm going to take the 2x plus 4y equals 22, and I'm going to take this 5 and I'm going to substitute it in for y because y is 5. So I'm going to say 2x plus 4 times 5 equals 22. So now I'm just going to solve. 2x, 4 times 5 is 20. It's a two-step equation. I'm going to subtract 20 from both sides. And I get 2x equals 22 minus 20 is 2. I'm going to divide both sides by 2. And x is 1. So my point of intersection here, my x coordinate is 1, my y coordinate is 5. Next problem. 5x minus 3y equals negative 14, and x plus 3y equals 2. So look at those two equations and tell me which variable we're going to eliminate. Which variable has the same coefficient but different signs? We're going to eliminate y, correct? Same number, different signs. What operation are we going to use to eliminate the y's? We're going to add, correct? So I'm going to add the two equations together. Tell me what you get when you add these two equations together. You should get 6x equals negative 12. Now solve and tell me what the value of x is. So x is negative 2. Now this next part is just like the substitution we did in the previous lesson. So I want you to pick which equation you want to use, 5x minus 3y equals 14, or x plus 3y equals 2. Plug in x and you tell me what the value of y is. This one's a little different, isn't it? We don't get a nice pretty number for y. If I've done it correctly, I got y is 4/3. So these two lines intersect at the point -2, +4/3. So this is one that graphing would not work very nicely because we'd have to sort of estimate that, and substitution might not work real well either because it might be just a little bit of a pain to deal with. But that is where those two lines intersect. Okay? All right, this next one, first thing I want you to do is decide which variable you're eliminating and add your two equations and tell me what you get for the next equation. I'm eliminating my x's. When I add them together, I get negative 2y equals 12. I divided both sides by negative 2, and I got y is negative 6. If y is negative 6, pick one of the equations and substitute negative 6 in and tell me what x equals. I got x is 33, so these two lines intersect at the point 33, -6. This would be another one that would not be very fun to graph, right? We'd have to have a big graph. So this is one that elimination works better. Now, what if we're looking at a system of equations? They're both in standard form, and we see one that has the same coefficient but the same sign. How can we eliminate two things that are equal to one another? What operation would work? We would have to subtract, correct? Now, remember, you guys know negative sign subtraction, it kills us. We have to be careful with this. So I see my y's, they match exactly, same coefficient, same sign. When it's all the same, I subtract. This is where circling that minus sign to me is very important because I have to say this in my head. I'm doing 2x minus 1x. So 2x minus 1x is just x. Y minus Y is 0. That's eliminated. And 7 minus 1 is 6. So I get x equals 6 here. I don't even have anything else to solve, but I still have to find y, right? So I get to pick my equation. I like the bottom one just because it's got some nicer numbers. So x plus y equals 1. I'm going to plug in 6 for x. So 6 plus y is 1. I'm going to subtract 6 from both sides, and y is -5. So don't forget to write your answer as an ordered pair. 6, -5 is the point that these two lines intersect. Okay, next one. 4x plus 3y equals 18, and 4x minus 2y equals 8. Notice my 4's here. Same number, same sign. When it's the same coefficient, same sign, I subtract the two equations. So 4x minus 4x is 0. X was eliminated. 3y, this is where you got to be careful. 3y minus a -2y. What is 3y minus a -2y? It's 5y, right? Minus a negative becomes plus. And then 18 minus 8 is 10. So I'm going to divide both sides by 5, and I get y is 2. So now pick the equation you like. I'm going to pick the bottom one just because it's got some smaller numbers. So 4x minus 2y equals 8. I'm going to take that 2 and substitute it in there. So 4x minus 2 times 2 equals 8. And I can already tell I'm going to run out of room. So 4x minus 4 equals 8. I'm going to add 4 to both sides, and I get 4x equals 12. And I'm going to divide both sides by 4, and x is 3. So these two lines intersect at the point 3, 2. Next system, -5x plus 2y equals 22, 3x plus 2y equals -10. Look at that system and tell me which variable we're going to eliminate. All right, we're going to eliminate the y's, right? Because they both have a +2. Since they have the same number and the same sign, how are we going to eliminate them? What operation are we going to use? We're going to use subtraction, right? Be careful with subtraction. -5x minus 3x is -8x. 2y minus 2y becomes 0. We eliminated the y's. And 22 minus a -10. What is 22 minus a -10? It's 32, right? Minus a negative would become plus. So I'm going to divide both sides by -8, and I get x equals -4. Now, pick your favorite equation of the two that you see. I'm going to use the bottom one. If 3x plus 2y equals -10, and x is -4, I want you to substitute and solve for y. I got y as 1, so we need to write our answer as an ordered pair. These two lines intersect at the point -4, 1. All right, one more. X plus 2y equals -4. X plus y equals 2. First, tell me, what variable are we going to eliminate? We're going to eliminate x, and what operation are we going to use to eliminate it? We're going to subtract, right? So I want you to subtract these two equations, and I want you to solve for y. Okay, at some point I forgot to press record again, but I got X was 8. Double check your work and make sure that's what you got. And then tell me what the point of intersection is. Where do these two lines intersect? What's the solution to this system? These two lines intersect at the point 8, -6. Okay, you are ready to do some practice.